Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 31. And in this episode, I am very excited to be joined by the author of the MassTransit framework, Chris Patterson. Hey Chris, thanks for joining us and welcome to the show.
Hey, thanks for having me on the show. Excited to be here. Looking forward to talking about MassTransit.net, all the things we can come up with. So thanks for having me on the show.
Oh, you're most welcome. Definitely looking forward to talking about MassTransit, but also seeing your notes that you did earlier on Google Docs and adding things like Kubernetes and service messages has made me even more excited about this chat, so that should be good. So now, obviously you do a lot of work on MassTransit, which we'll be talking about today, but before we delve in, could you give our listeners a quick intro into your background or what it is you do?
Sure, yeah. So I'm a software developer by trade. I've been building software since I was a teenager in high school. Actually, even junior high, but I don't even know that translates globally. So I've always built software. I've been doing .NET since probably 2005. Before that, everything was C++, assembler, everything. Anything you can possibly think of in a language, I've probably used at some point, except JavaScript. No, just kidding. I've actually had to do some JavaScript at this point, although I favor TypeScript in that regard. So I built software all the time, and most of my experience, even my first major real gig, was building connected systems using NetBIOS. So I've always built distributed applications that connected over network protocols. And so when I started to get into messaging back in the early days of MSMQ, I mean, we're talking in the 90s here. So, some people probably weren't even born yet. I've always kind of built these message-based applications and built custom frameworks and libraries around it. I've always been kind of a back-end server type of developer rather than a front-end developer. So I've always had to build applications that talk to each other, and obviously did web services in the late 90s via ASMX with the original classic ASP, which I think was C. I can't even remember. I think it was C. Maybe it was VB script. I don't even remember. But we've always been building kind of connected applications. And so, we had started using a lot more MSMQ in our applications. So back in 2007, I was in Austin for the first alt.NET conference. And at that point, I met Drew Sellers, and we were talking about some of the problems and challenges we had around applications. And he was looking to use MSMQ and didn't quite, follow everything that needed to be done. I had been using it and found that a lot of the patterns were reproducible. We looked at what was in the landscape at the time and decided, let's just write our own. How hard could it be? It's just a library on top of a message framework. How hard that could be? So we started MassTransit back in 2007. I think the first initial releases landed in 2008. And some of those early releases, from what I found out about a month ago, are actually still in production. Like pre-0.8 versions of the code are still in production. So that was kind of crazy. But that's what happens when you write code, and it tends to run in a fairly static organization. So anyway, MassTransit's been around for, I guess, 14, 15 years now. It's obviously grown tremendously. We no longer support MSMQ because MSMQ should just be gone from the world. So we've attuned more to like RabbitMQ, Azure Service Bus, Amazon SQS. We still support ActiveMQ. It's definitely the least used transport of the MassTransit stack. And then recently we've added things like Kafka and Event Hub to support data distribution use cases for like event streaming. So yeah, it's been a lot of fun. So it is a hobby, which some people laugh and say, how can a hobby be used by so many companies? Because it is used globally by companies and decision support systems and emergency response systems. And it's surprising how it's everywhere. One of the challenges is people say, well, who's using MassTransit? And, I don't have that web page that has like the logo of every major company because MassTransit is free and open source. So it isn't like someone has to register and pay to get their name on a slide of all the companies that are using the product. So it makes it kind of hard to answer that question. But based on the download usage and the email addresses of people that I get random questions from, it's used a lot. So.
Yeah, I was going to say, it's kind of, if this is just a hobby project on top of your main job, and so many companies are using it, you've got to do a lot of support now as well. That must be quite scary, I guess.
It can be. At the beginning of the pandemic, when everybody was kind of locked down, everybody was sitting at home. Like, people were craving content. Netflix was like, we're limiting bandwidth because everybody's watching 720p. Now we're going to give you 480p. We have no bandwidth. Everybody's sitting at home watching Netflix. And I thought that would be a great opportunity. So I sat down, I set up my rig to be able to do live video streaming, and I started streaming how to use mass transit on Twitch. And it was a great way to kind of connect and, in a nerdy sort of way, communicate with other humans throughout, this lockdown period. But it really spawned a lot of interest and put a lot of content out there. I ultimately replicated it out on YouTube so that people could go back and watch and like learn along and kind of see how different parts of it. And I ended up doing hours. I mean, there's over 50, probably near 100 hours worth of content out there. And that really kind of helped answer a lot of the questions, because you're right, the support load was getting high. I mean, questions on Stack Overflow, direct emails, a lot of that stuff would really build up. And for one person, it's tough. Now, the interesting thing is there are companies that do support mass transit, and some of them might surprise you who they are, because you would think, oh, well, don't they have their own solution? And it's like, well, yeah, they have commercial solutions, but if a customer is using mass transit, they aren't going to say no to consulting dollars. Consultants are consultants. Will work for anybody if there's money involved. But then I also have a relationship with Improving in Dallas, so they'll do some support, and they have a lot of customers that use mass transit, and I'll refer a lot of people to them. But I do run a 24/7 Discord channel that if I'm awake, which, that's the operative word, if I'm awake, and I see a message, I'll usually respond to it. I'm surprised how much traffic I get in there in just the weird hours. But, it just goes to show, if I look at the analytics of the doc site, I mean, everywhere from around the world, you can see based on the time zone as it kind of rolls, which part of the world is, actively using the project and looking stuff up. So yeah, it is a lot to do, but it's sustainable so far. I mean, fortunately, there's enough content out there and people can figure it out. And if they don't, they've got Stack Overflow, GitHub discussions, Discord, everything. So they generally figure it out eventually.
Yeah, that's quite cool. You mentioned about like Kafka and Event Hub, which is like using like event streaming. That's quite different than just a standard message broker. Do you find it quite difficult to have the same abstraction library working over both, like two different ways of doing things, two different ways of doing eventing?
Yeah, that's actually a good comment. It was probably a couple years ago, even prior before that, the requests kept coming in for Kafka. Why is there no Kafka transport for mass transit? And I kind of just came back and said, well, because Kafka isn't a message broker. And if you go to their webpage, they're like, Kafka is a message broker. It's like, no, it isn't. It's a log file with a really exotic API on top of it to make it look like a message broker. It has headers and it has a body and, all of these things, but it is not a message broker. And through my regular job, I have monthly meetings where I check in with a lot of the developer people within Confluent. So I have a monthly call with Confluent, the people who support Kafka. And we talk about this a lot, and we talk about the different patterns. And, the questions I would get is, from customers of mass transit trying to use it. It's like, well, how do I do request response over Kafka? And I'm just like, you don't. And they're like, but that's our message broker. And I'm like, no, it isn't. So when we started to look at how to bring a transport in for Kafka and Event Hub, because they're very similar patterns, we came up with the concept of riders. So with mass transit, you have a bus, and the bus is backed by a traditional message broker, whether it's RabbitMQ, Azure Service Bus, or even in-memory. If you're not doing durable messaging, you can use the in-memory transport, but I don't really recommend it for most use cases. But what we came up with is a concept of a rider, where we have these riders on the bus that, with alongside an existing bus that is a regular message-based broker, you could bring on other sources of messages. Message being kind of a logical concept of, I have some type that I'm going to pull into a system, and dispatch those to consumers, sagas, whatever, the same way you would a message coming from a traditional message broker. And so by doing this, we were able to make it so people could create endpoints to consume from topics, whether that's Kafka or event hubs on a event hub. And it turns out that it works really well, because you're able to use the same programming paradigms, writing consumers or sagas, but use them with, a theoretically higher rate message transport like Kafka. So it's worked out really well. It's give a consistent experience. The crazy things that come up are, oh, well, how do I handle retry in Kafka? Because with a regular message broker, you're removing messages from the queue, but with Kafka, it's just an offset in a file. So it's like, you can't write it to the back of the queue, because then you're going to have, or the topic, because then you're going to have multiple, and you can't schedule because there is no scheduling or delayed delivery mechanism in Kafka. So if you go out and search, you'll find that there's a number of different approaches that people have done to try to do retry in Kafka. I don't have a good answer for it. I believe in blocking retry, that if you're consuming from a partition in Kafka and you can't write to the destination, stop. Because if the destination isn't available, you're not going to get any better by skipping the message that you're currently on. So there's a number of different patterns, and we're trying to come up with some good usage stuff for the next release. But it's just those are the differences that you see. You don't really publish and fan out. You produce a message to a topic, and then that topic is consumed by multiple consumer groups. So it's just a different experience, but a lot of the patterns mapped over. So we did it that way, and it's worked really well.
So does that automatically, for example, for event hubs where that stores like the offset to like somewhere like blob storage, do riders automatically handle that persistence?
Yeah, so writers automatically handle the checkpointing, whether it's Kafka or Event Hub. So they'll keep track of that, and you can configure the timings. Some people like to monitor consumer lag in Kafka, and so you can set the checkpointing to be very aggressive and say, well, I want to checkpoint like every 5 seconds because I want to know if my consumer lag is over 10 seconds, which would be ridiculous with Kafka, but some people do it. But yeah, that consumer lag metric is important to know to see how far behind your consumers are from the events that are being produced. So yeah, the checkpointing is handled by both, under the covers. Again, MassTransit is a framework. It's sitting on top of the Confluent client or the Azure event host processor or whatever. So it's just letting that do the dispatching, and it can tune those checkpoint parameters so that those are auto checkpointed either to blob storage, or I think Kafka does it through, I think they do it through Zookeeper, but I think with the latest versions, they also do it through like a roll-up topic. But anyway, yeah.
I'm kind of aware that I'm kind of wondering because maybe some of our listeners might not be used to event-driven architecture and the different ways of doing things. I wonder if it's worth stepping back a bit and maybe covering some of these different terminologies. Like we've talked about event streaming, and then we've got messages, but you've got things like messages, events. Maybe if we skip out event sourcing because that's something completely different, even though it's got event in the name. Is it worth us just demystifying some of these differences before we dig a bit deeper? Each of the listeners are going to have different experiences, and some will understand what we're talking about and maybe some won't.
Yeah, we can definitely kind of cover some of those terms. So when we're talking about an event-based architecture, an event-based system, and even beneath that, when you're talking about a message-based system, the first atom to think about is what is a message? So if anyone's done any type of programming, they've had parameters that they pass to a method. And after they get 5 or 6 parameters that they pass to a method, they might create a type that includes those parameters. And so they pass a reference to an object that has 5 or 6 different parameters in it. Well, in MassTransit, a message is just a type. So you create a class or a record or an interface that has a number of properties on it. And that type is then considered a message. And that message is serialized out to whatever format it needs. In most cases, everybody uses JSON these days, and is written to the message broker as the message body. So what MassTransit does is it takes those types and saying, I want to send or publish this message, and the differences are subtle, but they're sensible. And it takes that message and it writes it out to the message broker. And then MassTransit is constantly pulling messages from those brokers and dispatching those messages to consumers. I like to think of MassTransit as kind of like the JMS of .NET. Java has JMS, which is an abstraction of messaging. MassTransit kind of does that because it's allowing you to use different message transports with a consistent API. And .NET doesn't have a JMS. So anybody who's done Java is like, oh, well, I just use JMS. Well, with .NET, there isn't that answer. And the way it does it is very similar to ASP.NET. And when you look at the latest ASP.NET core, you create a controller. Your controller has a number of dependencies, and your controller has action methods. And each of those action methods is really a type that controller can consume. And it just happens to be mapped to a URL that comes in through the web server. So when you think about that action method, in MassTransit, a consumer is just a class that has an iConsume interface on it with the message type specified that gets mapped to a consume method on that class. And what MassTransit does is it will create instances of your consumer, either through the container or directly if you aren't using a container, although pretty much everybody's using a container these days because of the way that the generic host and everything works with .NET now. For each message that comes in off the broker, it will create an instance of consumer, and then dispatch that message to the consume method on your consumer. So it's kind of, they call it the Hollywood principle. Don't call us, we'll call you. Once you've registered your consumers and hit start, as messages come in, mass transit's going to invoke your consumers and let those run. And it handles everything like concurrency and, acknowledging the message on the broker and, not acknowledging it if your process crashes. And there's a whole bunch of configurations you can put in place as far as like retry policies and outboxes and partitioning. And I mean, there's so many different middleware filters that you can put in place on that. So that's kind of the basics of how messages are dispatched through mass transit. Is you have some type, you either publish or send it. You can send it directly to a specific queue, whereas most cases people just publish because it's a publish subscribe system, whereas your consumer says, I'm interested in this type. And mass transit will wire it up. So if anybody publishes that type, your consumer will get an instance of that message. And if you have two separate consumers that are both interested in the same type, they get registered on separate queues. And when they publish one message, it fans out so that each queue gets a copy of it and processes it on its own. So it's a really nice, loosely coupled way to build a system because the consumers are isolated. They don't have to read from the same endpoint. And if one of them fails, it doesn't impact the other consumer. So it's that publish model where everything, creates a copy and it's handed independently. So if one consumer can't talk to, say, a remote web service, it doesn't affect this consumer that's just writing stuff to a local database.
Yeah, I really like that pattern. It's almost like inversion of control, where you've got, rather than the publisher knowing about the consumers and calling them directly, the publisher is just publishing a business event, something has happened, and then the consumers just independently on their own can just consume them and do that single responsibility principle, do that one thing, which is about that event. Like maybe it's sending an email out or whatever it is. And I really like that because it's also, well, I mentioned it's doing one thing each consumer, so it's single responsibility. But you've also got, what's the other one, open close principle, where you can add more consumers and nothing else needs to change. It's just another consumer responding to a business event and doing its own thing. And I really like that pattern. It makes it nice and clean and maintainable, I think.
Oh, I absolutely agree. And what's funny is you mentioned it's kind of like dependency injection in some of the early design notes, which I have a flip binder of that I think I still have. I might have thrown it away at this point. But when we were doing the initial designs for mass transit, that was like, how do we make dependency injection or inversion of control work across a message broker?
I guess it's more dependency inversion, not dependency injection, I'm thinking, because it's kind of...
Yeah, you're absolutely right. Yeah. And I meant to say dependency inversion because that was kind of the thing, is we were like, how do we make it so when I just produce a message, it just resolves the types and makes it go across the network? So that was what we were thinking about when we originally drew the design doc, is how do we do dependency inversion over the network?
Speaking of dependency injection, with, like you said before, that .NET now, you'd have to fight to not use dependency injection. So that's I really like that. That's just out of the box and works. And like you said, with the consumers, it's kind of, I've been recently playing with MassTransit. To be honest, most of the time, up until recently, I've been using like RabbitMQ or Azure Service Bus native clients, and now I'm using a MassTransit, which I'm really loving. The thing I'm really loving is all the stuff I don't have to do, because MassTransit does it for me, like you mentioned. Going back to like where I was going with the dependency injection, is because now there's just these MassTransit consumers, which is just a class. And if I want to inject something, then I can just use the standard way of doing things by injecting it into the constructor, and it just works. And it just feels so clean.
Well, that's good. I like to hear that the patterns are applying. What's funny is when we started mass transit, there was like I think there was like spring.net. I think there was Castle Windsor. And if you went to a room full of people at a conference and said, hey, who here is using dependency injection? And there would be like one hand go up in the back, and it was Jeremy Miller who wrote Structure Map. So it was like, okay, so nobody's really using dependency injection at this point. And now, like you said, it's ubiquitous, and at least in the .NET Core, .NET Standard areas.
Yeah, what's interesting, I think if you go in between now and what you just said then, time-wise, if you ask the same question and you said who's using dependency injection and what container are you using, you'd probably get like 5 different like Autofark, Ninject. There's a whole bunch of them. Where it's interesting with .NET now, I used to default to Autofark, but now I just use out of the box because it just works. And it's quite interesting the way things are going.
It's interesting you point that out because I've seen the same thing if I look at the download stats. As I used to be a huge AutoFac user, I have systems in production that are heavily built around sub containers and child containers and AutoFac this and this, that, and registries and tenant IDs and just crazy amounts of complexity that you could build with AutoFac. Things that should have been separate programs, honestly. But we built that with AutoFac. And now if you look at the download numbers, the fact that extensions dependency injection comes out of the box with almost every .NET new, it's pretty much everyone is using that. And it's why. So MassTransit has up to this date supported 5 different containers. We used to support more. We used to support Unity. We used to support a ton of them. Prior to version 8, MassTransit supported out of the box like 5 different containers. So structure map, simple injector, Castle Windsor, AutoFac, MSDI. And with version 8, we've just said, you know what? Extensions DI is the norm. Every container has been forced to adapt to the extensions DI patterns as far as iService collection and iService provider if they want to stay alive. So we've just finally decided, you know what? This stuff is dependent upon by everything. If you use Entity Framework Core, you're using all of those things. So let's just make those as kind of core dependencies and then let everything work around it. Because like you said, now it's, if you look at the usage of the containers, it's significantly in favor of extensions DI over everything else.
Yeah, it's kind of sad, really, because if you think like yourself, you obviously spend a lot of time working on open source with MassTransit, and with these different containers, there's a lot of people that have put an awful lot of time into these containers, and if now it's just easier out of the box to not use them.
Oh yeah, it's people who've worked and spent a ton of time building containers, and I think the phrase is Sherlocked. Once Microsoft takes it and puts it out of the box, it kills all the open source versions of it. And it's unfortunate because I know what it's like to pour a ton of love into a project, and if Microsoft came out with their own abstraction of messaging and basically copied MassTransit and then had their own, I guess there would be a sigh of relief because believe it or not, it's actually a lot of work to maintain and support this. And it's weird to think, okay, if I make this change, because if it's a hobby project, which, it is a hobby, it's a business, but it's a hobby. We can say that all we want. But, it's like, if I make this change, how is that going to impact people downstream? How are they going to upgrade? Are they going to have to upgrade everything? Is it a forklift? Or are they able to just add new services built with newer versions and they fully interoperate with the old ones? So yeah, it's like you can't just go out and just, chop off a couple tree limbs and build something else off the side of it. You really have to think about the longevity and how it impacts others.
Yeah, that's it. When you start an open source, air quotes, hobby project, and it goes viral, which is kind of in one way a good thing. In another way, suddenly you have to support it, or you don't have to, but you know what I mean? It's suddenly expected. And especially if you're just doing that in your own spare time. What was I listening to? I can't remember what podcast it was. I was listening to one the other day, and they were talking about this kind of thing, and it was interesting. Where I think it was one of the .NET Rocks ones. Actually, I'll include a link in the show notes to whichever one it was, and they were talking about how someone starts an open source project in their own spare time, and then businesses that use it suddenly assign a developer full time to help support it, and suddenly that developer full time is spending more time on it than the person that created it. And I don't know whether it's hard to control, or I suppose it depends on the project, really.
Yeah, I could definitely see where that would be a thing. I have a pretty broad list of contributors, and admittedly, most of the contributors add, small fixes or documentation updates or, just comment consistency updates, which is great. It's nice to see so many people actually looking through the source code and looking and making changes. I have a few major contributors who have added significant parts to the code base, and then I ultimately have to own them. As a maintainer, that's one of the questions that comes up all the time, though, is someone is like, hey, I want to add support for this database in this environment. And I have to think, okay, is this widely enough used? It's significant enough to make part of the core project. And am I willing to maintain it? Can I test it locally? So on and so forth. Because ultimately it comes down to that, is I'm going to have to own it. as maintainer and owner of the project. So it requires a level of scrutiny, and sometimes you have to say no.
Yeah, it definitely makes sense. That's an important skill to learn, to be able to say no. So going back to the different transports, we mentioned RabbitMQ and Azure Service Bus. How do you handle the differences between these transports? So, for example, Azure Service Bus has queues, topics, subscriptions, where Rabbit has exchanges and queues. Have you found it works quite well being able to abstract on top of those two different concepts? I suppose it follows a similar kind of pattern, I guess.
And that's the thing, what you just said. It's a similar kind of pattern. You have in Azure Service Bus, you have topics and you have queues. And you can set up a subscription in Azure Service Bus to forward to a queue. Or you can actually forward to another topic. And when you go to RabbitMQ, you have exchanges and queues. And in RabbitMQ, queues are the only thing that can hold messages. And exchanges form, for lack of a better word, an ephemeral message fabric in memory. So when you send to an exchange, it's immediately routed through those exchanges and land in one or more queues. So it's very quick in that respect. Whereas in Azure Service Bus, if you write a message to a topic, that topic then puts them into the subscriptions. And if the subscriptions forward, they kind of read and feed out to the queue. Or in the case of Azure, you can actually read directly from the subscription. The subscription is a queue in and of itself. So things that are additive, like subscription endpoints, for instance, MassTransit has normally everything in MassTransit is a receive endpoint, which maps ultimately down to a queue. With Azure and the way MassTransit supports the additional transport capabilities, you can actually create subscription endpoints in MassTransit that map to a subscription on a topic that only get messages from that topic. So it's basically the ability to use the capabilities of Azure Service Bus on top of what the base capabilities of MassTransit are. So it's a huge distinction, because when we first wrote MassTransit, we created kind of the lowest common denominator API. And it made it so like, well, how do I use this in RabbitMQ, or how do I use this in Azure Service Bus? And it didn't translate. And so it was like, we can't lowest common denominator that, because then we have to throw a bunch of not implemented exceptions if it isn't implemented by that transport. It's a very painful experience for the developer. So what we did is we basically turned the whole thing upside down and said, okay, well, we're going to have a base set of core MassTransit functionality. And then each transport is going to extend that base functionality. So if you'll notice, when you're writing a MassTransit application in the first code, you're like, okay, well, I'm going to add MassTransit, and I'm going to register my consumers, my sagas, so on and so forth. And then I'm going to say what transport I'm using. I'm going to say I'm using Azure Service Bus. And then within that configuration block, then you can configure the different broker-specific things. You can wire up specific subscription endpoints or receive endpoints if you want to, or you can just use the defaults and say configure endpoints, and MassTransit's going to configure all the topics, subscriptions, queues, bindings, everything for you. And it's going to do that whether you're on ActiveMQ, Amazon SQS, SNS, or RabbitMQ. It doesn't care, because if you're using the out-of-the-box functionality, it maps one-to-one regardless of what broker you're using. It's given us the ability to allow access to all the low-level transport features, which you can opt into through, like .NET C# pattern matching, and saying, well, if this configurator is a RabbitMQ configurator, then I want to change the type to this and do this and that and the other. Otherwise, don't do anything, because I'm not using that feature.
I tend to use Azure Service Bus when deployed, but playing around with MassTransit this morning, I then got it so locally it was the same consumers were running over RabbitMQ, just spun up in Docker locally, because like basically using Docker spinning up the database. Now I'm spinning up RabbitMQ, so Docker Compose up and it spins up. But the only thing that had to change was my program.cs and the startup, like basically what you were describing before. So none of the consumers changed or anything. And I've now just got a flag saying like which transport I want to use. And locally in the local settings.json, I've got it using RabbitMQ. And then when deployed, it's using Azure Service Bus. And as I say, it's just the startup code, which is slightly different. And that's it, really. So it just works really well.
Yeah, that's awesome. I mean, I know many people that do that. They run RabbitMQ locally for testing, and then they deploy to Azure and run on Azure Service Bus. And you're right, it's an awesome use case. in your startup CS, you just check an environment variable and say, what's the transport? Or, you use configuration, because obviously I configuration is a big thing, but you just say, hey, which transport am I supposed to use? And it's really the actual transport specific configuration is a small block of the overall configuration. So it's worked out nicely. So I'm glad that worked for you.
Yeah, definitely. And I think also, I mentioned before about all the stuff that MassTransit seems to do that you would have to do manually yourself. And just things like, so when using Azure Service Bus and using the client libraries, creating those topics in Azure Service Bus, creating those subscriptions against the topics. And then the scenario I've just described where locally I want to do it in RabbitMQ, and I would have to manually do those too, where MassTransit just does both of those things for me out of the box. And yeah, it's something that I'm going to start using a lot moving forward, where, as I say, in the past, I've just used the native client libraries. But yeah, this is definitely something I'm going to be using a lot moving forward.
I'm just thinking that would make a good video topic for YouTube. So
With the whole Docker locally thing, I really like that for integration tests as well. So with the ASP.NET Core Web Application Factory integration tests, where I'm kind of favoring those integration tests over unit tests, and I spin up database or whatever it is in Docker Compose, and then run the integration tests over them. So that I'm testing business requirement, the actual consumer of the API or whatever it is requirement, rather than each individual class and mocking out everything else, because that just takes so much time. But having this Docker Compose, which can do Docker Compose up, so it can spin up the database, RabbitMQ. Some of the stuff I'm doing is Azure Storage, so spinning up Azurite, all within the same Docker Compose. And then you can just develop locally, completely locally. All the tests can run against all that stuff in Docker. I just find that works so well.
I completely agree. It's been a super enabling technology. And most of our teams at the company I work for have started moving over to GitHub Actions, and it works there too. So we're able to run automated tests in our GitHub Actions. We can say, oh, we need these 3 additional containers spun up. So before we run our tests, and we'll run integration tests in GitHub Actions. We'll spin up Postgres, RabbitMQ, a couple other services, and everything will run in isolation, because otherwise it was okay, well, we need to have a test Azure Service Bus namespace. We need to have a test this and a test that. It's okay, well, when we run in the unit tests, we'll just run against RabbitMQ locally. We'll verify that it works. And you're right. We'll talk against a real Postgres database. We'll spin it up. We'll apply the migrations at startup for the test fixture setup, and then we'll just start running the unit tests via just a regular .NET test. But they aren't really unit tests. They're full end-to-end integration tests written in NUnit. But they do the full end-to-end using the real components, and there's no reason to mock anything out. Yeah, it takes 4 or 5 seconds instead of 200 milliseconds, but honestly, it's a build that takes 4 minutes total on GitHub Actions. Because the nice thing about GitHub Actions is in your job description, you can say, hey, just do all 4 of these different things at the same time, and it spins up 4 instances and starts running them. And so that local experience translates to the CI/CD capabilities you're getting with GitHub Actions, and it's just awesome because it just works. I mean, I realize Docker is definitely charging money now because they have to make money somehow. But when you talk about enabling game-changing technologies, Docker is one of them.
Yeah, definitely. And they're charging money for Docker Desktop, but you can run the Docker engine without that. So and I can't remember the exact figure, but you've got to be a pretty big company to have to pay that anyway.
Oh, yeah, I think you're right. Yeah, for the individual developers and such, there's no charge. And it makes sense. Get the big companies who have the spare change to write a check once a year so they can stay in business. I'm totally cool with that.
Yeah, definitely. And if you think going back to the whole writing unit tests, mocking out every single layer of the implementation detail, how much time that costs in developer salaries versus paying the Docker Desktop license.
That's a good point. That's why every developer on your team should have an awesome laptop instead of some janky old machine. We've been making that argument for 20 years. I need a faster computer. It's worth this much, and you'd have to spend a day proving that it would save you that much time.
This is the advantage to me being a consultant. I just use my own gear. So I've just got a really high powered desktop, and I insist on not using clients' laptops and stuff that they send through. No, I've got my own gear. I'm using that. And it makes such a difference. Like stress levels as well. If you've got a really slow computer, that can be quite stressful. It's actually surprising how big a difference that makes.
No, you're absolutely right. Good gear matters. You got to have good tools to do your job well. If that means you have to get them yourself, so be it.
Looking back at the feature set of MassTransit, you've got this thing called requests, you've got like requests and responses, which normally is kind of, I'd think of like REST APIs where you make a post request and you get response back. I guess I wouldn't naturally think of requests and responses in an event-driven architecture. Looking at your library, it seems to abstract a lot of that away from you, so it feels like a request and response. Can we talk a bit about how that works?
That's a good question. I hadn't really thought about that much. So yeah, you're absolutely right. When people think of an event-driven architecture, the last thing they think of is request response, because you get the purists who are, at the podium or the lectern saying, when your producers should not know anything about your consumers, and you shouldn't, you should just fire and forget. And in most cases, that's true. If you're accepting an order, you just need to accept the order and write it to a queue and be done. You don't need to wait for a response because you may not get it. The back-end system may be down. I mean, partial availability is a thing. I may have fulfillment services on the back end being upgraded, and I won't get that immediate response like I would expect with like an HTTP request. And that's one of the main reasons people move to a message-based system is, okay, if I can write the message to the broker, I've accepted your request. Have a good day. You can check back later. But it's that check back later that really comes into play, because eventually, even in an event-based system, you're going to have to be able to come back in, typically from an API endpoint. I mean, we're in the API economy. Everybody exposes APIs for everything. And they're going to come in with that API request that's going to need a response. And in the early days of kind of event-driven architecture, we talked about, we'll just create a cache at the edge that has all the data in it, and you'll just, that way you can read from the cache. And they talked about building this whole separate eventing model to build up, read stores that have view state that you can then query, using a query at the web API to check to see if it's there. And yes, you can still do that, but databases are really quick. Traffic loads really haven't gone up for most companies. Not everyone is web scale. So to say that, you need this big, massive distributed separated read-write architecture, it sounds great on paper, but from the complexity of the developer managing it and this whole eventual consistency model, yes, there are still practical use cases where that makes sense. But there are also cases where it doesn't make sense, especially for companies of a size that just aren't doing Google scale workloads, which, let's face it, it's 99.9% of us that aren't doing Google scale workloads, even though we think we're cool. So the request response support was really put in because if you think about a request and a response in a message-based system, let's start at HTTP, request response. You make a socket connection. You transfer a piece of data to the server does something and then transfers a piece of data back to the client. In a message-based system, you write a message to a queue, another process reads that message from the queue, does something, writes a message to another queue, response queue, and then the client reads from that response queue and accepts that response. It's the same thing. It's just you're using queues instead of a socket connection to transfer data. So it makes sense. And when you think about it that way, that's how requests work in MassTransit is we create a request client. Each bus has its own response endpoint when you create it. So if you actually use request response, it starts up that response endpoint. And then it will just send messages to, and actually publishes them by default. It just says publish because you have a consumer out there that is listening for that request or it's subscribed to that request. When the request lands on that consumer, the consumer looks at the response address, which is in the message headers, and then sends the response back to that address, which then gets picked up by the client and simulates request response over messaging. Why would we want to do this? Well, people still do a lot of request response. We have APIs. They pass in an identifier and say, get order status. We have to go get the order status. And we don't want to keep and maintain a separate read store that is, eventually consistent from the source of truth. And I see this a lot of cases when people are using sagas in mass transit. Is like a saga will kick off an orchestration of some complex back-end operation, and then they want to come in and check on it. So in many cases, you'll have a saga that subscribes to that request event so that it correlates to that particular saga instance and allows that saga to make its own deterministic business logic, similar to like an aggregate route in domain-driven design. It'll say, oh, you're asking me if this order, what my order status is? Okay, well, I will look at my status and say, okay, I am currently waiting for fulfillment, and then I will respond to that request from the saga itself back to that request client, which might be in, say, an API controller. And the reason that makes the most sense is because what's the alternative? Okay, what are we? Is the controller going to open up a DB context and then do a query against the database and ask for some column and make a determination based on some business logic in the controller to determine the status of the order? That to me seems like a bad plan because you've now coupled your controller to some business logic happening in a backend system, versus just defining a message contract of get order status and then order status being the response type and managing that through messaging.
I know you mentioned sagas then, and this is something I would like to come back to. But if you weren't using a mass transit saga, but you were using consumers to do the concept of a saga, so as you say, you've got an aggregate, let's use the example of an order going through different states through a system, but you wanted to manage that with your own event handlers. That very first create order command, whatever you want to call it, that triggers that saga. Is there a benefit to using the request response for that initial and start the thing going versus just using a REST call to an API that puts the next message onto the queue?
That's a really good question. And the classic architect example, it depends. In systems where, say, for instance, you have a legacy system and that system doesn't provide like a unique identifier for the order. Let's say they just submit a list of cart items and expect to get an order ID back. This is very common because so many people thought identity columns were cool in databases and they would just return your order ID as the next identity key that came back. Very bad idea, but there are systems out there that do it. And those APIs around them were built around that thinking. So in that case, you might use a request response to say, okay, I'm going to do a submit order and I'm expecting a response of order submitted or order submission accepted because I may produce an event called order submitted. So having a separate response type for that request response conversation can be useful. And you can really build it both ways. The way I do the consumers in mass transit now is there's an extension method, is response accepted, I think it's called. And if you just do a fire, if you just publish the event and say, okay, submit order, and you don't put a response address on it, you aren't doing it with the request client, the consumer can check and say, hey, is someone waiting on a response for this? And if they are, I'm going to do X, Y, and Z and then respond to them. Versus if they aren't waiting for a response, maybe I'll do something different. So I can make decisions based on the context in which the caller produced the original message. Does that make sense?
Yes. Yeah, it sounds very similar. As you say, it feels like both, for that initial request to start off the saga, either would work using like this request response, then your initial business logic is within the consumer, or just being a web API endpoint that posts the next message. Hey everyone, so during editing I realised that in the conversation with Chris we hadn't mentioned quite an interesting point regarding requests and responses over a message broker versus a standard API call, and I thought it was important enough to warrant adding a quick additional comment to include this before we move on from the topic of requests and responses. Basically, with an API call, obviously that API needs to accept incoming network connections and have a port open. However, when making a request and receiving a response that is orchestrated via a message broker, that's not the case. Both the caller and the callee are both making their own outbound connections to the message broker. So doing it this way, you get extra security too. So all of the logic is just a bunch of consumers in console applications, without having to open any incoming connections or worrying about ingresses and that kind of thing. And it's not only more secure, but it also feels way simpler too. Anyway, sorry about the interruption and back to the show. You mentioned sagas then. So if you then, rather than manually implementing like a aggregate workflow, if you use MassTransit sagas, so I've not actually tried this, but I read through the documentation, and it sounds like you've got a concept of persistence where you've got to have something else to store the state. Is that something else just your database? So MassTransit is basically using something like Entity Framework to write your entities to the database.
Yeah, so let me go into that for a little bit. So sagas, and MassTransit supports two types of sagas. The one we talk about the most is the state machine sagas, where you can define states and events and correlate them together and use them to orchestrate workflows. Sagas are interesting because they're stateful. And as much as people say they want stateless web services and all this other stuff, let's face it, state has to be somewhere or nothing changes. So sagas are stateful workflows, for lack of a better phrase, that respond to events, are identified by a unique identifier, and are persisted in some database. And yeah, it's usually the database that all the rest of your data is in. If all of your business data is in Postgres and you're using Entity Framework Core for that, MassTransit has out-of-the-box support for Entity Framework Core. You define a class map for your Saga to persist the properties of that Saga instance data, that state portion of the Saga, because state machine sagas are split into two parts. You have behavior, which is the state machine, and then the state, which is the actual data you're storing. It's kind of like your bag of data that you keep whenever an event correlated to that Saga instance is received. So it will load that state and then execute that behavior against that state. So it's like a call stack in the database, so that you're not, having a bunch of stuff waiting around in memory, in call stacks. But yeah, it's so that state is stored in whatever database you're using. If you're using Redis for your data, you can store your sagas right there in Redis. If you're using MongoDB, if you're using Azure Cosmos, there's a bunch of them. And that's the whole point, is you're storing it in the same place that you're storing your data.
Gotcha. So it's another case of MassTransit just doing stuff for you that you don't need to do. I guess when I started reading about sagas, just initially, I got a bit confused because it was talking about storing state. And in my head, I was already storing stuff in the database. So I'm thinking, what is this state I'm storing? And I was thinking, is this yet another thing I've got to store? But then as it clicked to what it actually meant, it's actually just doing my main database entity rights for me. I thought, actually, that's quite nice. So I think for the current use case I'm currently doing, we're actually converting over an older code base to use this. So it's kind of harder to just let MassTransit take over that workload, but maybe not. It's something that's worth looking into. So that's why I'm kind of almost doing a Saga-like flow, but just using consumers and doing it manually. But it might turn out that, because we'll be using Entity Framework, what we're doing actually, we can just let MassTransit do it.
Yeah, that's an interesting migration pattern. And yeah, admittedly, most people are working with existing code bases. But if you previously had work that was done in like an API controller action method or a service method that was loading up a DB context, loading some data, making some changes, saving some data out, using consumers as a first step for that makes total sense. I hadn't even really thought about that. But that's a strong approach. And what you've come to realize, as you pointed out, is that sagas are just doing that entity load and save for you. And it's one root table that has some certain constraints. It needs to have a certain ID and a field to store current state. But it's a DB context. You can have, I don't recommend going too crazy on this, but you can have joins and you can bring in other tables, and you can use the DB context is scoped. So you can bring in other loads and manage that unit of work and do everything as part of that same transaction that was started by MassTransit when it loaded the Saga instance from the DB context. So yeah, makes a lot of sense.
Cool. Do you find, just speaking of Entity Framework and other dependencies that MassTransit has, do you find that as Microsoft or whoever, as they create new versions, is it quite difficult to stay on top with breaking changes and all this kind of thing?
Funny you should mention that.
I was going to say that the listeners can't see you laughing right now, but
funny you should mention Entity Framework Core 6 versus Entity Framework Core 5. Yeah, when Microsoft released .NET 6 and they released Entity Framework 6, there's a ton of breaking changes in .NET 6. And they were very clear about it. They're like, hey, these things are fixing, and for the right reasons. I mean, Entity Framework Core got a lot faster in .NET 6 because they jettisoned some of the garbage. But you have to deal with that. And as a framework author, it was like, okay, so how do we support that? Because what we found in like the bug reports, if you run an open source project, I guarantee you the day after Microsoft releases a major version of .NET, you will get 5 bug reports of people saying, hey, this doesn't work with .NET 6. It is so frustrating. And then, of course, you'll get the people, hey, I just installed a, first alpha preview of .NET 6. I'm super cool and awesome. And hey, MassTransit doesn't work with it. And I'm like, hey, good for you.
I was going to say, with all the really early pre-releases now, that must be even worse because I think people are more likely to just try out the cutting edge before it's anywhere near ready. And then because they want to use it in their projects, they somehow expect all library authors to magically have got it to work.
Yeah. Remember when I said earlier that you have to learn when to say no?
Yes.
I didn't even install .NET 6 probably. Actually, I just installed .NET 6 about a month ago on my main desktop. I mean, and I've been building to .NET 5 up until then. And the only reason I had to install .NET 6 is because now with MassTransit 8, if you're using .NET 6, it requires EF Core 6. If you're using .NET 5 or earlier, it requires EF Core 3 or 5. So basically, it's just 3 and 5 are compatible. 6 is completely broken. So it as an author, you have to draw a hard line and say, this is what we're supporting on these frameworks. And there is no reason to support EF Core 6 on .NET 5 because, hey, guess what? It doesn't work. It requires .NET 6. So
do you find that you get people forgetting that you're doing this in your spare time and almost being rude about it?
Said any open source author anywhere. Is there a toxic sense of entitlement that people who are getting something for free are owed something?
Exactly, yeah.
I think that's a general sense in the open source community for sure. If you pay attention, you can certainly be aggrieved by the fact that someone was rude and said, hey, your product did this and I need your help right now. Again, I just ignore it. I mean, I run a 24/7 Discord channel, and sometimes people will post similar type assertions that like, hey, how do I get this? And I'm doing this. And it's like, sometimes they're doing things that they just don't realize the framework was not designed to do. They're trying to fit a square peg in a round hole. And you just have to say, that's really not a use case that, MassTransit really addresses. And sometimes they'll be insistent that it should. And sometimes you just say, hey, good luck. I hope you get it to work. I think people have figured out that if I say good luck in Discord, don't expect like another response for a while. It's not to be rude. It's just like, hey, if it works for you, great. But I don't have the brain cells to burn on that. That's a hard problem. And I don't know that I have the right answer.
Yeah, I think a lot of people need to just remember that. I was going to say, especially when people are doing things for free, but I would say anyone, just have respect for other people, and but especially if someone's spending their own free time working on a project that you're getting for free, and I'm sure a lot of companies will be making money from that, right? You're not. I think people just need to remember to have respect for other people. So going back to MassTransit, one thing that is on my list, maybe this afternoon, I don't know, it depends how much time I've got left, is there's a section on testing. So I'm looking forward to having a look at this. But how does, from a MassTransit point of view, how does the testing work there?
I've always put good unit testing support into MassTransit because I've always believed in testability, and I have to test the framework. I have to make sure it works. So I have to write tests against it as well. And if you look at the testing code base that's in MassTransit, I mean, there's thousands of unit tests. And if you look at the evolution of them, I've had to continue to change them as, a container has become a bigger part of what people are using. MassTransit has a built-in test harness. It has an in-memory transport. It has in-memory Saga repositories. It has a lot of in-memory message data repositories. I mean, all of these things that can support in-memory testing so that it can be very fast. And it has a number of fixtures that allow you to assert that things happened. You can check to see, did a consumer publish a message? Did it consume a message? Was a message sent? And so there's a lot of collections that can be observed. And because messaging is by its nature asynchronous, you can't just call a method and then check a result. You have to wait because some thread in the TPL is going to, in the background, pick up that, task. It's going to dispatch that message, and then it's going to, the consumer is going to process it. So you can't just check something immediately after calling a method because it isn't instantaneous. And so mass transit has a number of test harnesses that allow you to set up the in-memory bus, add your consumers to it, and then you just start publishing messages. You say, okay, well, I want to publish this message, and then I'm going to await, and I'm going to await on harness.consumed.message type. And then once that message type has been consumed, then I'm going to maybe go and, check if something happened, or check if, a message was published by that consumer that is going to be used by some external system. And so that's been really helpful to kind of test things. Now that you're testing sagas and state machines and repositories and things that are injected through dependency injection, I've had to kind of evolve that test harness strategy to add support for containers and add support for multiple consumers and make it more consistent with how people are configuring applications. And so it's evolved, but the testing harnesses are great. They let you check your ins and outs. It's up to you to check, kind of the side effects of whatever your consumers are doing, whether they're writing to a database or, however they produce that. But yeah, I think the testing support in mass transit is really good. And I've done a couple of videos on it, and I've definitely evolved it. It's improving even better in V8. It's going to have some easier test harness structures that are going to be more akin to, you're always testing with a service collection in your unit test, and you're setting it up just like you would any other way, so that like your dependencies work and things like that. Because that's more and more what the requests have been lately is, how do I test this since I have this dependency that has to be injected? So I've focused a lot of the changes in V8 additions, because the old stuff still compiles, but around making it easier to test container-based bus instances and consumers and sagas and such.
Yeah, very nice. Yeah, I think a combination of using your test harness and what we were talking about before, you mentioned side effects, but we were talking about Docker before, spinning things up in Docker, a combination of using your test harness to do all the stuff and verify that things have happened, but then afterwards also just directly querying the database, has this side effect actually happened? That's kind of like a pattern I quite often use, where to avoid testing any implementation detail, as we said, spinning things up in Docker. But then the assert side is just the test is doing a direct query to the database saying, has it actually changed? Is what I expect to happen, has that actually happened in the database? And then combining that with your test harness, that sounds like a really nice pattern.
Yeah, it's a good way to get there. And I mean, you just reminded me, one of the things that I'll test is like the order example before, is if I have an order saga, I'll do the submit order message in the top of the test harness. And then after that's happened, I'll actually use the get status request response client to say, okay, well, I'm going to check and see if that saga is in that order is in the correct state. Did that order get accepted? Is it in this processing state? Rather than going to the database and checking for an entity to be there. But you can also just, query the Saga repository and check for a state as well. But, if I have that request response support in the Saga, I will usually check that with an additional test that verifies, okay, well, I've added an order. Now can I check the status of that order to verify that part of the behavior?
Gotcha.
Does that make sense, where the Saga is responding to that request to check its own status?
Yes, yeah. Well, initially, where I was thinking about the request and response, I was thinking about it as being, the entry point into the saga, so that initial first message to kick off the saga. But from what you're saying, it sounds like you can query the saga at any point to find out the status.
Yeah, so the saga, in the case of creating a state machine saga, you would have an event in your saga, and now you can specify that it's read only, so that it doesn't lock the database. It doesn't, try to do a write of no change, because that can create concurrency issues. But you would have an event in the saga, such as like a get status event. And when the request client produces get status for a particular ID, such as like they hit an API endpoint, it says, okay, well, this is my order ID. I want to get the status of it. Instead of in the controller going to the database and trying to find that order, just send that request with that order ID in it. The saga would get that event. It would load that instance of the state from the database. It would execute that event behavior, which would say, oh, okay, well, the instance is currently in this state. I'm going to respond with an order status message, plugging that state in the timestamp and whatever last updated, whatever model you want to put in there. And then, then that saga event is processed, it's done, and the request client gets that back. And that's actually the place I use it the most, because I want to go and ask, typically that's the use case. I submit something, I want to check the state. I want to, is my order accepted? Has my order been shipped yet? And that's the most common one, is like, has it shipped? Has it shipped? Has it shipped? I need it now. I need it now. So, but yeah, that's a super common use case that I find, is using requests to actually query the state of a saga. Because you would do the same thing with like a domain aggregate. You wouldn't go out to the database and query the aggregates table to find out its state. You would, in effect, call a method on an aggregate route to say, okay, what is your order state? Has this order been accepted? And those are questions that you would ask an aggregate route. You would do the same thing with request response to a saga. And that way, all the locking and concurrency and methods for loading the data from the database are the same. It's the Saga repository.
Yes, yeah, that makes total sense. And it makes much more sense, the whole request response thing going via eventing now. Now I think about it that way. So going back to your Google Docs where you were rapidly typing notes before we started this call, I've been quite looking forward to your entry about Docker and Kubernetes and how this fits into the overall strategy. So I'm actually a really big fan of Kubernetes, and I do kind of pretty much use it everywhere. And I hadn't thought about that MassTransit would act any differently in Kubernetes. So that's why it piqued my interest when you put that entry in the Google Docs. Would you use MassTransit differently in a Kubernetes environment?
I don't think it's a matter of differently. I'm trying to think of a good example that would fly here. Kubernetes is definitely enabling. It takes Docker and puts it in production, and it does it in a way that gives developers a lot more control on how their applications are scaled and how they're managed. And if anything, it's made it nicer to be able to deploy services that scale horizontally and deploy multiple instances of container. It does introduce some questions, because there's always the question of, okay, well, if I have one instance of the service, what happens if I have 5 instances? And by default, MassTransit load balances. So if you start up 5 instances of the same service, it's going to have 5 instances reading from the same queue, and you're going to get load balancing round robin across that queue. So you immediately get faster consumption across that. You don't have to set up load balancers and routers. You're just doing it by creating more instances. The thing that brings up for some people, though, is when they produce events that are meant to be received by every instance of the service, such as like an invalidate cache event or something like that. And that's where they need to specify, like in the configuration, okay, well, for this consumer, I want it to have an instance ID of a GUID or something, so that every time it starts up, every instance of the service gets its own queue endpoint for that. That is temporary. Maybe it goes away because it's just for receiving events to like invalidate a cache or something. But there's just some things like that. If anything, it's a nice natural fit to create scalability in messaging, because you can just spin up more instances. And we see this a lot with like the Kafka consumption, is you'll have the same consumer group, because you want to read, the set of messages once within a consumer group, but you need to increase your ability to read faster. And when you spin up more instances, MassTransit, as long as you partitioned your Kafka topics correctly, if you have 8 service instances running, Kafka is going to manage assigning those partitions to different instances of the service for you. So it manages that load, and you're able to consume more quickly across different partitions. So it scales really nicely. It's just been a super enabling technology. And like we've mentioned early on the show, being able to just spin up Docker containers and be able to spin up like a persistent service right next to my services for, kind of like what we used to call an operational data store, is just, I need a quick store, and it's easy to just spin up Postgres in that same environment to have like a data store for like a Saga instance or anything like that. So it just gives you so many options and flexibility, and you can test the exact same thing locally on your local machine, which is awesome.
Yes, yeah, definitely. That's a really interesting point about the example you gave with flushing caches. So for messaging, how I'm currently using it, I use it like the standard topics and subscriptions, where some business event is published to a topic, and then each area of the business or of the code base that's interested in that event creates its own subscription. And that area of the business can horizontally scale, and like the Azure Service Bus just manages making sure that only one of them gets it. But as you say, it's kind of, if you actually want all of them to get it, that's quite an interesting problem, I guess.
Yeah, and I mean, some of it has to do with the conventions of MassTransit. So MassTransit looks at message type names, it looks at consumer names, and it generates a queue name based on the consumer name by default. And some people override it. Some people want to make it unique, and there are a lot of configuration options for that. It's just an awareness of what do I have to do when I want to do this? Because like I said, mass transit does competing consumer load balancing by default. So the trick is like, oh, we have this common framework and we have this event consumer. And 6 different services use the same event consumer. Okay, well, when you register it, you need to give it a distinct name, because otherwise it's going to have the same name, and all of those services are, even though they're running a different service name, but they're running the same event consumer from their common enterprise framework. And it needs a unique name. Otherwise, it's just going to load balance with all the other instances.
Yeah. In my startup code, where in the Azure Service Bus specific bit, where it does that configure subscription and it specifies the name of the subscription to create, I've ended up just doing like name of my consumer. And then that seems to work quite nicely. So then I've got my topic, which is the business name, which, as you said, kind of just automatically uses the message POCO class name. And then the subscription is the name of the consumer. And I just find that works really well.
Yeah, good. That's the plan.
Nice. So another thing you mentioned in the list is about service messages. And so are we talking about like Kubernetes, Istio, and Linkerd kind of service messages?
Yeah, I mean, this kind of came up. I mean, 5 years ago, or maybe even 4, I was like, oh man, we got to build a service mesh for our next service. And now I'm just like, why would you want that? One of the cool things about both Docker and Kubernetes is it's easy to just add a service by DNS name and reference it by DNS name. So discovery is sort of handled by that. But everybody got excited about east-west communication and Istio and doing all this stuff. And it's very much focused around RPC. I mean, it's really designed to kind of handle that interaction. And so obviously the question is, well, like, how do we have an event mesh? And I mean, I guess I never really thought kind of in depth about what that would be. But when you have publish and subscribe and you've decoupled your producers from your consumers, that discovery is already handled. So I don't really need to think about it. So, I originally had thought about how I would apply service mesh patterns to mass transit. And I never came up with a good way that was consumable by developers, because all of it was highly complex. And if anybody's dug into Istio, hey, guess what? It's highly complex. So Linkerd isn't necessarily any better. So
Yeah, exactly. But I think those do lots of different things. So like one thing I would like out of the box in Kubernetes, which these service messages add, is like mutual TLS. But I kind of just want that, but without all the other gubbins that comes along with it. So the event mesh kind of thing, is that almost like the actor pattern?
You see, I don't necessarily know. It's funny you mentioned the actor pattern, though. I used to have an actor framework that I wrote when I was all into actor model, and I thought it was going to be awesome. And then I realized it's so edge and complex that it's another thing that only 3 developers are going to ever know how to do. But what it came down to is every time I built an actor model program, I wanted persistence. It's like, okay, well, I need my actors to be persistent because I'm not building a video game. I need to be able to store this state out to a disk somewhere. And hey, guess what? Saga state machines are basically like persistent actors. So at that point, I killed my actor framework and said, I'm done with it. I'll let Akka.net deal with that from now on. But yeah, no. So an event mesh is, it's the similar question. Is like when you think about an Istio and stuff, it allows you to do like routing and, like you said, TLS and translation to some respect. And I feel like event mesh is trying to be more like the next enterprise service bus type thing of like, okay, well, I produced an event in Kafka, but I want to consume it over here in Azure Service Bus, and like being that bridge. And, with mass transit and the fact that you're writing to an abstraction and can consume messages from a variety of different transports, it could be considered that it would allow you to have multiple event sources with the same behavior. Because you could just create a bus on Azure Service Bus, you could create a rider to Event Hub, you could and use the same consuming logic for that. So that kind of goes back to the nomenclature of is it a JMS for .NET? And yeah, it allows you to anything that is a block of JSON or a block of something that can be converted to a type and dispatched to a thing. Yeah, mass transit can do that. I mean, in Azure Functions, which is kind of the message dispatch and queuing and everything. It isn't a transport, but Azure Functions, when you do Azure Service Bus, it's doing all the underlying work of locking the message and doing all that for you. But you can use mass transit with it because you can just literally say, okay, well, this is the message I got. It's going to be it's from this topic, dispatch it to a consumer. And mass transit just runs the consumption pipeline and ignores all the transport code of mass transit because it's decoupled. It's used across the board. And you can apply that to anything, really. I mean, I have this long-standing backlog item of, let's just go full circle and make it so mass transit can sit on top of HTTP and your topics are URLs and your message is just JSON that you're passing in. And one of these days that might happen, but because why wouldn't it? I mean, it's a block of JSON that you're converting to a type. You can dispatch it to a consumer. Why would I not do that?
That reminds me, I saw in the list of transports, you've got gRPC in there. Is that quite a new addition?
Yeah, so gRPC support in .NET has gotten so much better. And the in-memory transport that mass transit has is within the same process, same bus instance. And I've had requests from people. It's like, well, how can I have a brokerless transport where I'm able to use my consumers to just like connect a backend system together? And so I got a wild hair and started firing around gRPC one day. And I thought, I can make a transport that just goes over the gRPC bidirectional stream and just uses it as a really smart socket. And yeah, it works. It's a great way to connect. It's super fast because, essentially it's in-memory, non-durable. So, but I can publish, I can subscribe, I can connect consumers. And I was surprised it worked. That was one of those weekend projects that like Monday morning, I'm doing a video on YouTube. I'm like, I cannot believe this worked, but it actually did. And check this out. And it's only been used by a couple people. And yes, it's released, but is it something that I would put into production today? I don't know. I'd be cautious because apparently there's some reconnect issues with it in the case of server failures. But yeah, it's pretty cool. But it isn't like it lets you take a generic gRPC request coming in from like a gRPC server and then dispatching it to mass transit. But again, if you have a type, you can run mass transit because mass transit has a receive dispatcher that you can just register in the container and it'll just let you resolve it and send a type straight through to the mass transit pipeline now. So.
That's fascinating, all the different ways of using this. So another item you put in your list, which I'm kind of scared of bringing this up because if we get talking about this, we could be here all day. Well, I'm just going to read out a substring of it. Rider versus Visual Studio. The longer sentence you put was Mac versus Windows, Rider versus Visual Studio. Why did I switch to a Mac for .NET over a decade ago? But my eyes just got drawn to the Rider bit because I'm a huge Rider fan.
Oh, well, good. It's nice to be in good company. I love Rider. I've been on a Mac for years, and when Rider came out and I realized I didn't have to run a VM to test Windows stuff anymore, I was pretty excited about that. I'd used Mono from the early times, and it's good up to a point, but inevitably you would always have to go back to Windows. I have not developed .NET on Windows since 2016. I would do an occasional test of different versions of Mass Transit on .NET Framework back then. I have, since Mass Transit completely jettisoned .NET Framework and went full Net Standard 2.0, I have not used Visual Studio. I have not done anything on Windows, and that's probably several years now. I use Rider because I've always been a ReSharper fan, even though it really bogs down Visual Studio. And taking that experience and having it native on a Mac has just been pretty solid. And like you said, it's a powerful tool. It's like having ReSharper, but fast because it's built on top of IntelliJ and it runs on a Mac and it's a native experience. And since Net Standard and .NET 5, .NET 6 runs native, and now .NET 6 even runs native on ARM64, the new Macs, which I don't have one because they're like back ordered to infinity. And they don't have a desktop yet, but I'm okay. I have a Mac Pro. I'm fine. I have more RAM than I ever need. So it's awesome, especially when you're running bunches of Docker containers. But yeah, I struggle with people who fight Visual Studio constantly because I'm just like, there's a better way, and even on Windows, Rider is good. So
what do you mean even on Windows?
I've never used it on Windows. Actually, I used it on Windows back when it first came out because, again, I was still supporting .NET Framework at the time. So I would test it. And I was surprised it was pretty much a clean transition. The muscle memory of switching from command keys to control keys was always a tricky one, though.
Yeah, I don't use it anymore, but I did have a MacBook Pro, but I had Windows installed on it. And the bit that got me was the FN key was in the corner where the control key would be, so I would always hit that. I've used Windows for many, many years, but like you, I used ReSharper for quite a long time. And then when Rider hit the scene, I moved to that. And I am a huge keyboard shortcut nut. So it's kind of like just basically getting the IDE to do everything for you and using all like the resharper functionality. And as you say, it's resharper does bog down Visual Studio. And in Rider, it's just super, super fast. More recently, I've been doing bits and bobs in Visual Studio as I've been playing with .NET MAUI because it's obviously a bit more up to date because .NET MAUI is in preview. And to be honest, Visual Studio is not that bad, but I do have ReSharper installed. Even if it does slow it down, I don't care. I've got to have ReSharper installed. But yeah, it's very cool.
I have Visual Studio Code installed because it supports live sharing. That's one thing Writer doesn't support yet is live sharing. And I found when I'm doing code reviews, like people will contact me and even people with my own company that are using MassTransit. I'll do live sharing with them because it just makes code reviews and like doing walkthroughs a lot cleaner. It's just easier to navigate the code and see it versus trying to do it over a Zoom session where you're getting like blurry video and everything. But yeah, Writer is fantastic. I can't imagine not having it.
I don't know where it's up to now. I don't think it's quite ready, but JetBrains have got the Code with me, which is kind of a similar thing. And I just find it such a shame there's not some standard protocol which both live share and Code with me can talk across. You've got a team. Each developer should have the choice of using the ID they want to use. And it feels like it's either all VS Code or Visual Studio or all JetBrains. And it's a bit of a shame, really, because if we had some kind of collaboration tool, especially now a lot of people are working remotely, that could just work across these IDEs, that would be so, so nice. I find you also lose context with these tools because quite often if I'm pairing with someone and I want to switch over to the browser because we're Googling something and I want the other person to see, I quite often use tools to annotate the screen, just to point at a certain bit or to zoom in, and all of that goes away, so I kind of lose a lot of context as well.
No, I agree with you though on the, when you have people collaborating, and even if I'm doing a live share, we'll typically have a Zoom where one person is sharing just so you have that flow and that context. So it's a hybrid kind of thing. And it's, I guess, having a big monitor helps because you're able to break it out, or multiple monitors if you're a multiple monitor person.
Oh, definitely. I've got 3 monitors. I quite fancy one of those, like, big stretching, massive ones. But then it's kind of, you've got to use something to, like, if you're screen sharing, normally I just share my whole screen, but then you'd have to use something like fancy zones and only share a particular window or something. I don't know. It's all good. Looking at when MassTransit started, it sounds like it's pretty much 15 years old now. Have you had like a 15-year birthday celebration?
I think it would have to be at the end of the year because alt.net was, I think, in October of 2007. So I guess the 15-year celebration would have to be and we didn't really release a version of it until early 2008. So yeah, I'd have to do it early then. We'll have to have like a 15-year birthday celebration. Get it its learner's permit.
That is so, so impressive. Right, so shall we do dev tips?
Oh, what's going to be a dev tip? I mean, Writer is my dev tip.
Oh, that's a good one. That's like the best dev tip ever. So my dev tip is basically a note-taking tool called Obsidian, which I've very recently been using very heavily. I've mentioned on the show before, I'm a big fan of Notion and still am, but I didn't really feel comfortable putting client work in Notion's clouds. I still use Notion for more personal notes and code snippets, but for local notes, I've been starting using Obsidian, and I've been so impressed. It's basically fundamentally a markdown editor, but it's designed for note-taking and acts very much like a wiki, having links between different notes and things. And there's lots of very, very powerful note-taking functionality built in. It's kind of hard to explain over an audio podcast, but there's tons of videos and there's a massive community around it. And I'll include a link in the show notes. And in the last episode where I was speaking about developer productivity, I spoke a lot about the power of note-taking. So if you've not seen that, I would definitely check that out. But yeah, Obsidian, I'll include a link in the show notes.
All right, I got one for you. I'm on a Mac, so this is going to be very Mac specific. There are 2 tools that are the first things I install on a new Mac. One is called Carabiner Elements, and another one is called Hammerspoon. We mentioned earlier in the show about the IDE and keyboard control, and these are the kind of tools that give you that same control over your Mac. Carabiner lets you map like the caps lock key to like a universal action key, because seriously, who does all caps? You get in trouble if you do all caps. So, I mean, caps lock one key access to any application on your system. That's powered by Hammerspoon, which I'll be sure to put some links in the show notes for this. But, the ability to snap windows to sizes, to define regions of windows, to have multiple configs, whether you're on your laptop screen or your larger monitor, the ability to move windows, resize windows, jump to windows, activate windows, launch applications, because if the application isn't up and running, it'll just start it and leave it right where you left off. So yeah, two of my favorite tools for the Mac is a mix of carabiner elements for that, what I call a hyper key, and Hammerspoon, which lets you write Lua scripts to completely control all of your windows, positioning, keyboard shortcuts, everything. Super awesome tools.
I'll definitely include those in the show notes. The second one sounds very much like Auto Hotkey for Windows.
It's similar, yeah. I mean, they both come from the same lineage of, the super active window manager, focus manager, everything. Intercept the keyboard and do stuff. Yeah.
Automate all the things.
Yes. But just don't make me touch the mouse or go to the menu to launch stuff.
When you mention the cap, so you're going to get me on another tangent now, but when you mention the caps lock key, I've actually globally remapped my caps lock key to my escape key because I'm a big VAR user for Vim.
Oh,
so,
yeah.
Not Vim itself, but I have the extensions for Rider and whatever IDE.
Right. The key maps, yeah.
The escape key is quite far away, and you're pressing it all the time when using Vim, so the caps lock's just there. It's perfect.
Yeah.
But then when I switch computers and then I haven't yet remapped it, I'm just constantly turning caps lock on instead of pressing the escape key.
I have caps lock globally disabled on all my computers, but I use it on Macs, I use it as the hyper key, which basically just translates to like Control Alt Shift Command or something. But it makes it so that whenever I'm holding down caps lock and I hit a key, it's like, oh, I jumped to my browser. Oh, I jumped to Zoom. Oh, I jumped to my chat window. Oh, I jumped to my iMessage window. Yeah, it's instant single key, and it's so much muscle memory that if I don't have it on the Mac, I'm completely screwed.
Yeah, I've got a whole bunch of tools where on a new computer, I'm just like, I don't know what to do. How do I use a computer? Awesome. So before we wrap up, where's the best place for listeners to reach out if they have any questions?
The best place to get in touch with me is, obviously GitHub discussions. If you have a larger question, drop into the Discord channel. I'll make sure that we have links for that. I'm active on Stack Overflow. Those are the general places I hang out. I sometimes respond to comments on YouTube. But yeah, Discord is the best place. Email works, although generally I don't enjoy unsolicited emails because usually it's people asking for, commercial support type things without having a commercial support agreement. But yeah, I'll get you some contact info.
Awesome. We can include all those in the show notes. Cool. So a massive thank you for joining us. It's been such good fun, like geeking out on not just MassTransit, but all the other stuff as well. Been a really great conversation.
Yeah, it's been a lot of fun. I'm glad to be on the show.
Cool. And a big thank you everyone for listening. A quick reminder that this podcast is sponsored by Everstack, which is my own company, providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, please do help me spread the word on social media. I normally use the hashtag unhandledexception, and I can be found on Twitter @Drakan, and my DMs are open. And my blog, danclark.com, has links to all my social stuff too. And we will include links to all the things, and it's going to be a long, long list we've mentioned in the show notes from today. And that can be found on unhandledexceptionpodcast.com.